Hello, this is Tyler Cruzen, Haran Chithranjan, and I'm Marty Tiss, and we are Team 2. This is our Battlefog Rube Goldberg machine project. In this presentation, we'll be talking about our mission statement as a team, our schedule in the Gantt chart, the customer needs and target specifications, the competitive benchmarking and a look at some of our competitors' products, and finally an economic analysis of the project. Here's Haran with some of our station ideas.
So during the project planning stage, we discussed many ideas from each of the group members, but three of the stations that we've narrowed down to are the Arduino Kick, the Spring Shot, and the Loop-de-Loop. So here we have a CAD model of the Arduino Kick. So we have the ball entering from the entrance ramp, and it's going to hit some pad here, which will stop the ball, and then a kick lever that is controlled by the Arduino will kick the ball down this ramp, this incline ramp, which will then travel to our next station. So our Spring Shot station will demonstrate spring potential energy and Hooke's law. And our Loop-de-Loop will demonstrate the law of conservation of energy, where it will show kinetic energy and potential energy. And now we'll talk about our mission statement. So we have a basic description of a product is it's a Rube Goldberg machine that teaches basic kinematic and energy concepts to 11th graders. So our target customers are going to be local 11th grade physics classrooms. So we're going to be targeting Blacksburg High School and Christiansburg High School. Some of the benefits of our product is a simple yet educational machine, and it's an interactive kit that demonstrates basic physics principles of motion. And a secondary market is local 8th grade science classrooms, because we can use some of the concepts as they are related to the curriculum of their science classrooms. And some of the constraints for this project, we have to have a minimum of 3 stations. There has to be assembled on a pegboard, and has to have an Arduino. One of the stations has to have an Arduino component and has to be easily stored. And now Marty will talk about our Gantt chart for this project.
So far in this project, we have completed most of the project planning tasks of the project, including the identification of customer needs, establishment of target specifications, and the search for intellectual properties literature. Currently, we are working on the concept generation, which includes making sketches of possible stations, coming up with CAD models, and doing mock-ups. And then next, after that, we'll be working on concept testing of those mock-up and the prototypes that we generated. We need to make sure that we continue to work to make sure that the red tasks here are not delayed, because those are on the critical path for our project. And if we were able to do that, then we should finish on December 1st with the presentation of our final results. Here is Tyler with an overview on our customer needs.
So in the table can be seen the list of customer needs, as well as a list of engineering characteristics. The customer needs were established through our interviews of potential customers, which included 2 teachers from Fairfax County, as well as students. And the customer needs can be seen in the second column from the left, and the engineering characteristics are listed across the top. And each of the customer needs were given weights, and each of the engineering characteristics were given number values for how much they correlated to each of those customer needs. And using those numbers, we were able to calculate which of the engineering characteristics were most important. And this is the target specifications table, which lists each of the engineering characteristics in order of importance. And you can see that the focus on energy was seen to be our most important task. And the entire chart is completed, including lists of marginal values and ideal values, with the exception of the energy left at the end of the demo, because we need to know the mass of both the ping pong ball and the velocity of the ball leaving the board. And in order to do that, we'll need to get a little farther in our project so we can get both those values. And next we have the competitive benchmarking. This is an example of one of the products that we use to benchmark, and this is the advanced Physics 1 starter bundle. And some of the applications for it, as you can see, are listed is Newton's second law, kinetic energy and work, as well as springs. And this product costs $855, which is significantly more expensive than our product, which Haran will discuss in the economic analysis.
So here is a graph of the economic analysis or projection of our product. So we chose a scenario 2 model. So the price is going to be dependent on the demand, and we thought that was it was necessary for our product because we're introducing a relatively new product to the market. So it's going to depend on how it's received. So the price is going to be $360, and it's going to decrease by $2 for each product sold. We were given a fixed cost of $11,250, and we estimated our variable cost to be around $45, which might change when we get to the manufacturing process of our design. So for the scenario 2 model, we have 2 break-even points. We have one at 55 cases sold and one at 105 cases sold. So we're aiming to sell around 79 cases, as that will give us our maximum profit of about $1,150. And but ideally, we're hoping for at least about $1,000 profit for our product. And now Marty will conclude our presentation.
In this presentation, we went over the first planning phase, mostly planning phase of our project, including tasks such as identification of customer needs and target specifications, and the initial and economic analysis of our project. Moving forward, we continue working on generation of more CAD models and sketches, and working on finalizing what our final product is going to look like. And then we can work on testing that product and making hopefully small modifications to make it the best it can be. And throughout this project, we will obviously continue making economic analysis, make sure that we are on target, and working to make it as profitable as we can make it. Thank you.